This is the lab that I do most of my testing research, my experimental research. This lab we call the hybrid vehicle power systems laboratory, because we study various energy storage and energy conversion devices for hybrid vehicles. Hybrid vehicles, of course, use both an engine and an electric drive system. So we test batteries of various types, supercapacitors, and we have tested fuel cells also in this lab. We try to coordinate the testing we do in this lab with the vehicle simulation work that we do in our offices over in the other building. This lab's been in existence for about 20 years, but we've only been in this particular lab for about 2 years. This is a new building. We have 3 different testers in this lab for testing batteries and capacitors. This tester is our main tester. It allows us to test batteries up to 50 volts and 400 amps in both charge and discharge. We test cells and modules as long as the module voltage is less than 50 volts. This particular device that's being tested now is a 4 amp per hour lithium battery, a very high powered battery that can be used like you would use a capacitor. The test that we're doing on this at the moment is to simulate its use in a hybrid vehicle. Now this tester here in the corner is for testing small devices. There are 6 channels. All the channels go to 20 volts, but 2 of the channels go to 20 amps, and 4 of the channels go to 5 amps. We test very small devices that we have to use only a few milliamps, all the way up to, as I said, 10 to 20 amps. Many of the prototype supercapacitors that we've tested using this machine in the corner. Now these 4 cells that are on the floor here are lead acid cells. They're special design that we didn't make, but we got them from somebody else. Uses both lead and some carbon in the negative. The object of that is to extend the life of these cells for use in hybrid vehicles. Most of the hybrid vehicles at the present time use nickel metal hydride batteries, and may use lithium batteries in the future. But those batteries are much more expensive than lead acid, and the lead acid industry is working very hard to try to be able to use their batteries in hybrid vehicles. So we've tested many very interesting small supercapacitors and also small batteries using that machine. Now this tester here is called an ABC 150, and it's for testing full battery packs. It can test batteries to 400 volts and up to 500 amps current. This tester will allow us to test complete battery packs that would go into hybrid and electric vehicles, and allows us to test combinations of batteries and supercapacitors together. So you can see that we have the capability in this lab to test very small devices, and in this machine to test battery packs for complete cars or trucks or even buses. This particular battery on the floor uses a special electrolyte that's called H904, and it's a new solution which people think will lead to very much longer life of lead acid batteries. And there's a local company in Placerville near Davis that has invented this special liquid, and we're helping them to test and evaluate it. Okay, these are nickel iron batteries taken from a fuel cell bus. The fuel cell type is a phosphoric acid fuel cell, and these batteries are very old, and we're trying to see if we can refurbish them so they can be used again in the bus. Now, these batteries in the front here, these gray batteries, are lithium batteries. They're 24-volt modules. They have 10 50-ampere-hour lithium titanate, which is a new type of lithium battery, which has very long life. Where most lithium batteries might have 2,000 or 3,000 cycles, these particular batteries are expected to have a cycle life of 10 to 20,000 cycles. And these batteries, these modules like this, are used in a fuel cell, in a hybrid fuel cell bus in Denver, being developed in Denver, Colorado. And we got these to test and evaluate to help the people that are developing that bus to give them the characteristics of the batteries. Our computer controlled all of the data. Here you can see that there's some data happened to come up on the screen there. This is a temperature chamber. We can put modules up here, or we can put cells up here, because every battery will degrade if the temperature gets to be too high. So high temperature causes batteries to degrade. Low temperatures causes them to have reduced performance. The resistance of every battery gets higher if the temperature gets low. Every battery, the energy stored is less at say minus 20 degrees C than it is at 30 degrees C. So in this chamber, we can test cells and modules down to minus 30 degrees C, which is like so we do is we put the cells or modules in here, set the controls to come to what temperature we're interested in. We take the leads out and connect it to one of these testers, and then run a test the same with the module in the test chamber as we would if the module was sitting on the floor at room temperature. So this allows us to determine the effect of temperature on the cycle life of the battery, and also on its performance.